Alright, boys and girls, this is lesson 4.8, which is the last section of chapter 4. We are going to solve some problems here using trig functions, and I'm sure some of you may remember this from geometry. Okay, angle of elevation versus angle of depression. Okay, so let's assume that you're standing down here on the ground, and you are looking up at someone in the gondola of the hot air balloon. Okay, that is an angle of elevation. Okay, this would sort of be like your sight line if you were looking straight ahead. Well, you should probably look straight ahead, not on a curvy line like that. Come on, Habit, get it right. So that would be the sight line if you just stared straight ahead. Okay, well, you're looking up, so that sight line with your normal sight line makes the angle of elevation. Now, same goes for if you're up in the balloon. If you're up in the balloon and you're looking down at the person on the ground, okay, this would be your sight line, looking straight ahead, okay, out into the great wide open, okay, Tom Petty song. Now, if I'm looking down, that sight line plus your natural sight line straight ahead makes the angle of depression. Now, if you notice something here, okay, these horizontal lines are parallel. Okay, little geometry. These are alternate interior angles, which means they're congruent. That's why these two angles are the same. Okay? So, the angle of depression of a buoy from the top of the... I don't even know how to start. I'm going to try. If it's wrong, I apologize. The Baregat Bay lighthouse, 130 feet above the surface of the water, is 6 degrees. Find the distance x from the base of the lighthouse to the buoy. So as you can see, they have a picture drawn for you, and they have a right triangle, all right, and theta is down here. But we know that the angle of depression, so if you were standing up here, okay, this would be your sight line out. This would be your sight line looking down at the buoy, is 6 degrees. Well, we just said that the angle of depression and the angle of elevation are congruent because they're alternate interior. So that means that this angle right here is 6 degrees. Whoops. It's a degree symbol. All right? So what do I have? I have opposite, and then I have adjacent. Well, that's tangent. So the tangent of 6 degrees equals opposite over adjacent. Now, since the variable's on the bottom, shortcut, since the variable's on the bottom, we take 130 and we divide by the tangent of 6 degrees. Now, since we're in degrees, make sure your calculator, degree mode, okay, or else you're going to get messed up answers. All right, round to the nearest tenth. I know it doesn't say, but nearest tenth, you get 1,236.9 feet. Always label your answers. Okay? So basically we're setting up trig equations based on our diagrams. Alright, now this one's a little bit more involved. Okay? Actually, the next two are. From the top of the 100-foot tall Altgelt Hall, as you can tell, I'm an English major, a man observes a car moving toward the building. If the angle of depression of the car changes from 22 degrees to 46 degrees during the period of observation, how far does the car travel? Hang on, swig of Diet Coke, hang on. All right, that was more like a gulp, but whatever. How far does the car travel? So this is what we're trying to find. Okay, that's what we're trying to find. That's X. Now, the first thing I should probably do is solve for D. Okay, find out how far it is from the car, where the car is now, to where the building's at. So I'm going to use this right triangle first. Okay? So, part one of this problem. Tangent. Opposite over adjacent. So the tangent of 46 degrees equals 100 over, Use the right variable. 100 over d. Okay? So, d is 100 divided by tan 46. So when I divide that, okay, I get about 96.6. Okay? So this is 96.6. Okay. Now, let me look at the large triangle. Okay, the large right triangle. All right. So, here's my 100 feet. Okay, that's still the height of the building. But now the length here, from where the car started to the building, how would I write that? Well, I would write it as x plus 96.6. Okay, now how am I going to write that in the equation? Well, we have tangent again because opposite over adjacent. So the tangent of 22 degrees equals 100 opposite over x plus 96.6. Boy, if I ever learn how to write, folks, I could be a really good teacher. I really could be. X plus 96.6. All right. Now, same rule applies. I know we have a variable on the bottom. I know we have the plus 96.6, but it doesn't matter. That's the same concept. So instead of just x, it's x plus 96.6 equals 100 divided by tan 22. Okay? So x plus 96.6 equals, I wrote a 9, folks. I said 6, but I wrote a 9. Okay? This is about 247.5. I did that in my head, by the way. I know. You don't have to tell me how smart I am. Okay, so now it turns into a one-step equation. Minus 96.6 from both sides. So, from the time he started watching the car, or from the time he started watching the car to current time, the car moved about 150.9 feet. Okay? So when you have a diagram like that, okay, you want to make sure that, all right, you got to use the small triangle first, then use the big one. Okay? Now the next problem is going to be just like this, but notice what they give you and what they don't give you. This is like the Macy's Thanksgiving Day Parade. There he is, the penguin. A large helium-filled penguin is moored at the beginning of a parade route awaiting the start of the parade. The two cables attached to the underside of the penguin make angles of 48 degrees and 40 degrees with the ground and are in the same plane as a perpendicular line from the penguin to the ground. It says see figure 4.91. I'm guessing, I'm just throwing this out there, I'm guessing this is figure 4.91. This guy. If the cables are attached to the ground 10 feet from each other, how high above the ground is the penguin? Sorry. All right. We need to fill in some information. Okay? First things first. That's the height the penguin is from the ground. That's what we're trying to find. Okay? The distance from one of the cables to the ground over here is x. We don't know that. Okay? Now, this is the 48-degree angle, and this is the 40-degree angle. Okay? The 48-degree angle, you can see, this is a larger angle than this one over here. Okay? Now, I'm going to set up an equation for the small triangle, the 48-degree triangle, and the 40-degree triangle. So let's start with the 48, opposite over adjacent. So I have tangent 48 equals opposite over adjacent. Now you might say, well, how the hell am I supposed to solve that? There's two variables there. I understand. Give me some room. Now let's look at the big 40. So we did this triangle first. Okay, that's where we got that first equation. Now let's look at the big one. Now remember, this little guy is 10. So I've got tangent of 40 equals opposite over, now that's 10 plus x. That's the length of that side. Okay. Now, what we want to do is we want to solve both for h. Okay? Now, h is on top. Since h is on the top, we multiply. So h equals x times tan 48. So that's the first, that's this one. And the second equation, h equals 10 plus x in parentheses times the tangent of 40. Now you might say, well, why are we doing all this? Like in the last problem, we could just do the numbers and it was fine. Yeah, except this time they put the variable in different places. Okay? So we had to set up both equations. We solved for h, which is really what we're trying to find. Okay? Notice how both of these equations equal h. What I can do, I'm going to go to the next page here, or the next slide. I can use substitution. In other words, I can set these two equations equal to each other. Okay? So, what's next? Well, I'll tell you what's next. On the right side, we are going to take the 10 and the x, and we're going to distribute. So this is 10 tan, well, that should be a 40, excuse me. Sorry. Okay, 10 times tan 40 plus x times tan 40. Okay, so I just took the 10 plus x and I distributed. Now, what I'd like to do is I'd like to get all the x's on one side. So I have an x on the left and an x on the right. So let's fix that. Minus x tan 40. So those cancel. Now, there's no combining like terms on the left side here. You literally have to write it out like this. Okay? Equals 10 tan 40. Okay? You can't combine those. Try as you might, you can't. Look at this left side now. Okay? I've got an x in both terms. I'd like to get x by itself. Well, I'm going to do that by factoring an x out of both terms. Okay? So, this is what I wind up with. Now, this is x times all that parenthesis. So if I wanted x by itself, couldn't I just take tan 48 minus tan 40 and just divide that to both sides? I bet you we could. So those cancel. So x. So I have to put this whole thing in my calculator. Alright? And when you do, you should get about 34.32 feet. And that's the right answer. Okay? Now you might say, well, you solve for x, not h. Well, since back here, these two equations both equaled h, and I did the substitution, basically I'm solving for h. All right? So that's the end of your problem. And that is the end of Chapter 4. Thank you for dealing with all of my grammatical errors and drinks of Diet Coke and coughs and all that other stuff. So that's all for Chapter 4, folks.